Right, today in geometry, we are looking at section 7.2, which is the converse of the Pythagorean theorem. So the converse of the Pythagorean theorem, remember, converse simply means we trade places with the hypothesis and the conclusion. So if the Pythagorean theorem is, if it's a right triangle, then a squared plus b squared equals c squared, right? So then the converse says if the square of the length of the longest side of a triangle is equal to the sum of the squares of the lengths of the other two sides, then the triangle is a right triangle. So the converse says if c squared equals a squared plus b squared, then triangle ABC is a right triangle. Okay? And again, this would be A, this would be B, and this would be C. So with the Pythagorean theorem, we start out knowing that we have a right triangle. Then we know a squared plus b squared equals c squared. With the converse, we start out knowing a squared plus b squared equals c squared. Then we use that information to say, therefore, we have a right triangle. So our first example, it says, determine if the given triangle is a right triangle. So I'm looking for, does 9 squared plus 15 squared, okay, is that equal to 3 squareds of 34 squared? That's what we're looking for. So 9 squared is 81. 15 squared is 225. Remember, over here, I square both of them. So 3 squared is 9. The square root of 34 squared is just 34. So over here, I'm going to add them up. 81 plus 225 is 306. 9 times 34 is 306. Does 306 equal 306? Yes, it does. So therefore, yes, it is a right triangle. So now some more examples. And it says, tell whether a triangle with a given side length is a right triangle. So first, okay, can we even make a triangle out of them? Remember that lesson. So 14 plus 22 is bigger than 26. So yes, I know that it will make a right, or that it will make a triangle. So now I want to see, is it a right triangle? So 14 squared plus 22 squared, does that equal 26 squared? And again, remember the hypotenuse would have to be the bigger side. So that's why I would set it equal to 26 squared. So 14 squared, 196. 22 squared, 484. 26 squared is 676. So add 196 and 484 together, I get 680. Is 680 equals 676? No. Therefore, this one is not a right triangle. Okay? So number 2, I have 10, 11, and 14. So first check, will it make a triangle? 10 plus 11 is greater than 14. It'll make a triangle. If it's going to be right, the 14 is the longer side, so it would have to be the hypotenuse. So I would set this up. 10 squared plus 11 squared. Does that equal 14 squared? So 10 squared is 100. 11 squared is 121. 14 squared, 196. Add these two together, so I get 221. Does 221 equal 196? No, it does not. So again, this one is not a right triangle. All right, my last one. 5 plus 6 greater than the square root of 61? Yes, so I could make a triangle. The square root of 61 would be the bigger side, so 5 squared plus 6 squared, is that equal to the square root of 61 squared? 5 squared is 25. 6 squared is 36. The square root of 61 squared is just 61. 25 plus 36 is 61. Does 61 equal 61? Yes, this time we do get a right triangle. Right? All right, flip our page over. Now we're going to talk about classifying triangles. Okay, so on the front, we just saw where some of them were right triangles, some of them were not. So if they were not right triangles, well, what kind were they? So that's what we're going to talk about now. So Theorem 7.3 tells me if the square of the length of the longest side of a triangle is less than the sum of the squares of the lengths of the other two sides, then the triangle is an acute triangle. So if c squared is less than a squared plus b squared, then ABC is an acute triangle. Theorem 7.4, if the square of the length of the longest side of a triangle is greater than the sum of the squares of the lengths of the other two sides, then the triangle is an obtuse triangle. So if c squared is greater than a squared plus b squared, then the triangle is obtuse. So if c squared equals, then it's right. If c squared is greater, so greater, obtuse, because greater than 90 is obtuse. If c squared is less, then less than 90, acute. So we're going to look at some examples like that. So determine first, can the segments make a triangle? If so, classify it. Is it acute, right, or obtuse? So first thing we do, add the two smallest together. So it's 4.3 plus 5.2 greater than 6.1. Yes, so it'll make a triangle. So now I'm looking for 4.3 squared plus 5.2 squared, and I'm going to leave this kind of a circle. How does that relate to 6.1 squared? So 4.3 squared, this is 18.49. 5.2 squared is 27.04. We'll leave this as a circle. 6.1 squared is 37.21. So add 18.49 and 27.04 together, and I get 45.53. And on this side, I have 37.21. The 45.53 is greater. Remember, this was my c squared. So c squared is smaller, therefore this is an acute triangle. So number 2, I have 15, 20, and 36. 15 plus 20, is that greater than 36? No, it is not. So this one, no triangle possible. So always check first to see, can you make a triangle? Number 3, 24 plus 30 greater than 6 squared, so 43. Yes, so we're going to get a triangle. So 24 squared plus 30 squared, how does that relate to 6 squared, so 43 squared? So 24 squared gives me 576. 30 squared gives me 900. 6 squared, remember, is 36. The square root of 43 squared is just 43. 576 plus 900 is 1,476. 36 times 43 is 1,548. 1,548 is bigger. This is my c squared. C squared is bigger, so this is an obtuse triangle. So number 3, obtuse triangle. All right, number 4, 12, 16, and 20. So 12 plus 16 greater than 20. Yes, it'll make a triangle. 12 squared plus 16 squared, how does that relate to 20 squared? 144 plus 256, how does that relate to 400? So when I add these together, I get 400 and 400. They are equal, so when they are equal, it is a right triangle. And on this one, this is actually a triple. If I had recognized this as a triple at the beginning, right off the bat, then I could have said, hey, it's a triple, therefore it's a right triangle. So that takes care of section 7.2, the converse of the Pythagorean theorem.